Today we're going to explore how to use Python to control parameters inside Houdini. And for this lesson, make sure you're in the technical desktop because this contains exactly what we need. It has the tree view, the Python shell, and your standard network parameter and view panels. Let's give ourselves a little more room with the Python shell. And let's collapse the shelf tools since we won't be using those. To start, let's make a sample test geometry. And let's rename it GeoDemo. And we're going to dive inside, double click, and we're going to make a platonic solid node, which defaults to a tetrahedron. And I'm going to give it a nice orange color with a color node. There we go, in honor of side effects. And then finally, I'm going to add a null output node, a good habit to develop. Let's rename these. Instead of platonic 1 and color 1, let's call platonic 1 our solid, and this will just be our color node. So we've created 4 nodes. We're now going to hop over to the Python shell and start writing some Python to control the various parameters of these nodes. But before we do that, I'd like to give you a brief overview of what Houdini gives you in Python. So I'm going to expand the Python shell. Look at the first line. It lets you know what version of Python we're working with. In this version of Houdini, we have Python 2.7. They are in the process of updating everything to Python 3. It'll probably take another version or 2 more before that's done, I'm not sure. But everything I write today will work with Python 2.7 or Python 3 and up. There's a function in Python called dir for directory. And if you call this function, it lets you know what's available to you in this instance of the Python shell. You have the standard built-ins, doc and name and what have you, but here is the key thing, the HOU module. If you just type in HOU and press enter, it lets you know this is a module. You can think of a module in Python as a folder that contains other modules, classes, functions, and things. It's called HOU, and it lets you know where the code lives on your workstation. You can see I'm using a Windows workstation. Next, we're going to call the directory function again, except this time we're going to pass in the Houdini module, and this will let us know what is inside the Houdini module. And there is a lot. In fact, it can seem a little overwhelming, but that's because this Houdini module essentially gives you everything you need to control virtually all aspects of Houdini. And so it shouldn't be a surprise that there's so many functions and classes available to you so that you can do anything you want. But today we're going to keep things simple and focus only on the node and parameter objects. So if you type in HOU, the HOU module, and hit dot, you get this pop-up and it lets you know what is available. And this is very helpful. In fact, by guessing, often you can find what you're looking for. So we would like to be able to get a hold of these nodes. So you might type in the letter N for node, or NODE. And you can see there is a node here, and it has a little f next to it. So if we double click node and hit enter without using parentheses, look what it displays. It says this is a function. That's what that little f meant. It meant it's a function. If you type in HOU dot again, and this time type in a capital letter N, you'll notice it pops up with different things. That's because it is case sensitive. And there is a capital node, and it has a C next to it. That's because it's a class. So there's 2 types of node things in the Houdini module. There's the node function and the node class. What we are going to use is the node function to grab the solid node, color node, and output nodes. Let's grab the solid node first. So we're going to call it solid, take the Houdini module dot the node function, open parentheses. When you type in the open parentheses, you will get a help pop-up. And more often than not, if you just read a few lines, it will let you know what this function does and how to use it. And that's a great time saver. Here they're saying type in the path to the node. I'm going to hit escape to close that. And if you come up and look at the tree node, this is how you can determine what the path is to the node that you're interested in. You start with the root node up here, come to the object or scene context. There's the geometry node, which we call GeoDemo, and then there's the solid node. So let's get that node, and we're going to call it solid. So we're going to take the HOU module, call the node function, and start typing in the path. And this also gives you auto-suggest on the path as well, so you don't have to have all these names memorized. So I can just use the down arrow and select the OBJ context, the GeoDemo node, and then come down to the solid node. And by the way, notice there's a pop-up with a lot more things. And this initially might confuse you a little bit because there's just one node. And what it's actually displaying is if we go full screen with the nodes, notice the platonic solid node has a little lock here. This is an asset that SideFX made for you, and if you double click, it will show you all that went into creating the platonic solid node for you. And in fact, this is multi-leveled as well. Not only do you have these nodes, but you can click on some of these others, and you just get a sense of how complex some of these tools are. But that's the power of using these pre-made nodes for you, is it really saves you a lot of work. But that explains what the pop-up is here, is that if you were to unlock the platonic solid node, you could go in and start grabbing any of the nodes inside of there. But we just want the solid node, so we're going to close it off. Now, if we type in solid and hit enter, it gives us a little overview. It lets you know that this is an instance of the SOP node class. Remember, SOP stands for surface operator, which is just your geometry nodes. Of type platonic. So where did this come from, this word platonic in lowercase? If you come up to the solid node and click the information tab, you'll see the path at the top, the description, platonic solid SOP, and in parentheses is the type. So this is a SOP node of type platonic. And then it goes ahead and lets you know which node. It shows the path to this node. So what I would like to do now is let's bring back the scene view, because we're going to make some changes and I'd like you to be able to see things change in real time, is there's 5 parameters here. The type, the orientation, radius, position, and rotate. Let's take a look over here in the Python shell at those parameters. If you type in solid dot, parameters, by the way, in Houdini Python are abbreviated parm, P-A-R-M. It just saves you a lot of typing. So if you type in P-A-R-M, you'll see there's a lot of things. There's parm and parms. Let's select parms just to see all the parameters. Okay, it gives you a tuple. You can tell it's a tuple because it opens with a parentheses, but then it just lists them. This is a little hard to read. So let's go full screen again. And what I'm going to do is I'm going to loop over all of these parameters and display them. So for P in solid parms, let's print P. There we go. And there are 9 total. But there are 5 parameters in the parameter interface. There are 5 controls for the platonic solid node. So what's going on? What's going on is the position parameter actually consists of 3 numbers, T1, T2, T3. By the way, notice it's not TX, TY, TZ. That's a little bit of a puzzle, which we'll cover eventually. Rotate also has 3 parameters, RX, RY, and RZ. So while there's 5 parameters, there's technically 9 different values that can be changed or can be controlled. And I would like to start by changing the type. So let's get the type parameter. The way you can do that is take your node, which we called solid, dot parm. And if you do open parentheses, it gives you a very nice, succinct explanation of what this will do. What this will do is if you give it the name of a parameter, type, it will return to you the parameter object. How did I know it was typed with lowercase? Well, if you come up to solid type and mouse over it, you can see it says parameter colon type, all lowercase. Remember, it is case sensitive. That lets you know what the name of the parameter is. So what is the current value of it? Right now it says tetrahedron. The way you get the value of a parameter is you call the eval method, 0. That's a little bit surprising. It says tetrahedron here, but the value is 0. What if we changed it to cube and took the type and evaluated it again? Now the type is 1. So how do we know what number goes with what value in the dropdown? You can find this out by clicking the little gear and selecting the Edit Parameter interface. This shows you the 5 parameters. By the way, each parameter has a little icon. That tells you what type of a parameter it is. So the solid type has this little 10 icon. And if you come over here on the left, you can see that's an integer parameter. The radius has a 0.2 icon. You can see that's a float icon. So that's a float parameter. And rotate has ... and they're blue dots, because over here there's green dots or blue dots. So this is a vector with 3 floats. So let's come back to type. And if you click menu, it lets you know on the menu, this is what it will display on the dropdown, but these are the actual values. These are the numbers that you will be working with. So let's switch to a dodecahedron, which has token 4. To change it, you can take the parameter, type parameter, call the set method, and pass in 4. Watch what happens when I hit return. There we go. We've now changed to a dodecahedron. Next, I would like to move this shape. So what I'm going to do is I'm going to have this shape move along the x-axis while rotating. So let's first have it move along the x-axis. So we go up to the GeoDemo node, and we'll start at x equals -10. Let's rotate this so we can see it. And we'll create a keyframe by Alt left click. Then we move to the end of this animation sequence, and let's change it to +10. Zoom out a little more so we can see it, and set a keyframe here by doing Alt left click once more. So we've now created 2 keyframes, and it moves our platonic solid from x equals -10 to x equals +10. Now, if we dive in, come back to the solid node, we're going to have it rotate around as it moves along. So we're going to come down to the rotate parameter, and these 3 numbers you can see are named Rx, Ry, and Rz. Instead of using keyframes, I'm going to use an expression. But before you type an expression, you want to make sure on the parameter interface that you've selected Python. HScript is the older way to do it. Python is the newer recommended way to do it. So the parameter expression I will use is just rotated as, we'll pass in the function time. So if we play it back and make sure the real-time flag is on, this is what we get. Okay, it is moving in the x direction, but I don't see much rotation. That's not surprising because time is going to vary from 0 to 10, which means as it moves along, it's only going to rotate 10 degrees. So let's instead multiply it by 100 so we can get faster and more noticeable rotation. So there we go. We have motion defined in 2 ways. The linear motion we defined using keyframes, and the rotation motion we defined using an expression. What I would like you to see is that when you get these parameters, you can actually work not just with values using set, but you can actually work with expressions and keyframes. Let's get this parameter. Remember, it's called Ry. So to get Ry, we're going to take the solid node, call the parm method, and pass in the name of the parameter we want. In this case, it's Ry. Now what I would like to show you is when you have a parameter, you can get its current value by calling the eval method. It's currently 0. If we scoot up here to say frame 120, you can click on the parameter name to toggle between either expression or value. The current value is 495.833. And if we call eval one more time, we do get 495.833. By the way, you don't have to scroll to the frame in order to find out what the value would be. There's another nice method that they give you to find the value of a parameter at a given frame or a given time. So we're going to take Ry eval at, and you can evaluate it at a specific frame or a specific time. If you do frame at 120, we get what we got earlier, 495.833. Now let's see what the expression is for this parameter. Suppose we didn't know. You can just type in expression on this parameter and hit enter, and it returns the string for that expression. Remember, to see, you can toggle between the value and the string by just clicking on the parameter name. Let's say we wanted to change this to 200 times time. We changed the type by calling the set method. Let's see if that works. If you type in set, and let's type in a new parameter, 200 times time, a new expression, we get an error. And the bottom of the error message is the key part. It was expecting a numerical value, and it got a non-numerical value instead. We passed in a string, an expression, and it was expecting a number. That's because this box here is defined to hold a float. So how do you change an expression? Well, let's come back to our Ry parameter and call set. Set is the naming convention when you're assigning a value to something in Python and in programming in general. Notice there's a set expression. So if we call set expression and this time pass in 200 times t, I'm about to hit enter, and you might want to watch this change. If I hit enter now, the expression has changed to 200 times time. Play it back, and it's now rotating twice as fast. Next, what we're going to do is now look at the keyframes. So we are going to go up a level to our geo node, and let's get a hold of that. So we're going to call it geo is Houdini.node /obj/and geodemo. If you type in geo and hit enter, notice it doesn't say SOP node. This is an object node, not a SOP node. A geometry object node just contains SOPs, and it's of type geo, and once again, it gives you the path. This is the parameter right here. Tx is the parameter where we added 2 keyframes. Let's see if we can access those keyframes from Python. Type in geo. My best guess would be to start to type the word keyframe and see what comes up. Nothing. Why is that? Because the keyframes are attached to a parameter and not the node. So what we need to do is get the tx parameter. We do that by saying tx is going to be, for the geo node, call the parm method and pass in tx. There we go. We have a parameter object called tx attached to this one. Now, let's see if there are keyframes attached to the tx parameter object. So let's start typing in keyframes. Now it's working. Keyframes returns a list of all the keyframes that you've created. Now, I'm going to go full screen here and do what I did earlier, where I loop over the keyframes and print them one by one, just so it's easier to kind of digest, because it returns a tuple of all the keyframe objects, and it can be a little overwhelming. So I'm going to do 4k in tx keyframes. Let's print the keyframe. There we go. So there's 2 keyframes. Remember, we made one at frame 1 and another at frame 240. But here, it lets you know that these are keyframe objects. One is at time 0, which is frame 1, and the other is at time 9.95833, which corresponds to frame 240. I just want to point out why that's the case. Notice time starts at 0, but we start counting the frames at 1. So if we were to count the frames starting at 0, the last frame would be 239. And there are 24 frames per second. So if you divide this by 24, you get 9.95833. So the last frame, by default, is actually occurring at t equals 9.95833. It's 10 seconds long. It's just the 10th second frame is not included. And then there's this v, which lets you know what the value of the keyframe is. The value of the first keyframe is -10, and the second keyframe is +10. There's a lot of other things that go into making keyframes, and we'll explore those in another video. For now, let's change one of the keyframes and add another keyframe. Let's get the second keyframe, keyframe 2. To get that, we're going to take the tx parameter, get a list of all the keyframes. It's actually a tuple of all the keyframes, and we get the last one. And the last one has index 1 because there's 2 keyframes and they're indexed starting at 0. So 1 is actually the second keyframe. If you type in kf2, you can see we did indeed get the last keyframe. Let's change the value. Instead of 10, let's change it to 8. So if we type in kf2 dot, let's start by typing set again. Okay, here are all the values that we can change, and one is set value. So for set value, let's change it to 8. Notice if we come to the very end, it still says 10, even though we set the value to 8. So that's a little confusing. The reason for this is what you need to do is you now need to override this old keyframe with the new one that we're working with. KF2 is now a new keyframe. We're changing its values and everything. And so we want to override it. So we're going to take our tx parameter and call set keyframe. Remember, it's case sensitive. I started off by typing setk lowercase, nothing there. But k uppercase, there's a set keyframe method. And open parentheses, it gives you a little bit of help information about how this works. So we're going to pass in kf2, hit enter, and now the value for this keyframe changed from 10 to 8. Lastly, let's make a new keyframe. If we go into the middle of the animation, let me bring back this scene here. As we scrub through, if we go to frame 120, which is roughly in the middle, the value is -1.05. Let's change it to 1.5, just so we can make a new keyframe. So I'm going to have a new keyframe, and keyframes are objects of type, are objects made from this class, HOU.Keyframe with a capital K. So that's how you make a new keyframe. Type in the module, and then the name of the class, and then parentheses, enter. So we now have a new keyframe, but there's no information in there. There's no time, there's no value. So let's go ahead and add that. So for the new keyframe, let's call set, and then we can set either the frame with set frame, or we can set the time with set time. Let's work with frame. We are going to set a keyframe as frame 120. Nothing there yet, but if we print out the keyframe object, there's now a little bit of information. Notice it converted the keyframe number to time. Now let's give it a value. We want the value to be 1.5. So we take our new keyframe, call set value, and we want it to be 1.5. So now if we print out new KF, we have a keyframe object with this time and this value. All we have to do now is to add it to this parameter. The parameter is tx, and we don't call add keyframe, which honestly, that's what I would have liked. We call set keyframe, pass in our new KF, and when I hit enter, there should be a new keyframe appear right here. Enter, there we go. And see the value is 1.5. So that is how you can use Python to change a parameter, inspect the expression controlling a parameter, and even change the expression. Look at the value of a parameter at any given time or any given frame, and also use Python to inspect the list of keyframes for a particular parameter channel and go through and either alter existing keyframes and add new ones.